Good evening, everyone. Maybe I'll start by saying thank you to the Clickhouse team for having me here to talk. I really appreciate it. I know I'm standing in between you all and the creator of Clickhouse, so I'll try to keep this interesting and hopefully pretty quick. For those of you I have not met yet, my name is Chris Crane. I'm a co-founder and head of product of a startup called FiveOneFour. A little bit about me, I started my career as a developer. It's been a long time since anyone paid me to write a line of code. So hopefully I can do justice to this audience, which I think is pretty technical. But I've spent the past 15 years of my career leading product teams, both at a series of startups and then more recently at big enterprises like Nike, where I worked with my co-founders who led global data engineering at Nike. We left Nike about a year ago to start FiveOneFour with this mission of bringing incredible developer experiences to the data and analytics stack. And this is based on this thesis or this realization that there's all these like best practices and workflows that are kind of common sense or really commonly available, at least in the world of software development and kind of modern web development, that are really hard to achieve or at least less commonly achieved in the world of data engineering. So things like running a local development environment that's an exact replica of your production environment can be pretty hard if you're running a big complicated OLAP stack. So we've spent the past year kind of building towards this vision of bringing world-class software development experiences to the world of data engineering and big data. We've been working on our portfolio of products, which I'll go over really quickly. First and foremost, we've built out an open source developer framework called Moose. Moose is what I want to talk about most today. Like any developer framework, Moose offers abstractions and utilities that hopefully make your day-to-day life as a developer easier and better. And Moose sits on top of some really cool open source core infrastructure technology like Red Panda and Clickhouse at the database level. And I'm going to talk about how we use Clickhouse. We've also got a commercial hosting platform called Boreal Cloud, which makes it really easy to one-click deploy your Moose applications into production. I'm going to skip over that for the most part today. And then hopefully at the end of this, I'll have 2 minutes to show you a quick demo of a prototype that we've been working on for an AI-powered data engineer. And that'll be pretty cool, I think, if we can get to it. So that's what you'll see with Aurora. But first, to start digging in deeper on Moose. So I want to actually get into the code and show you a demo of this working live. Hopefully the demo gods do not mess with me too much. But in order to set that up, I want to talk about a use case, which is one of our initial customers. So one of our first customers is called F45. They're a global gym franchise. It's actually Mark Wahlberg's gyms. There's like thousands of them all over the world. And one of the experiences that they offer their users is the ability to wear a heart rate monitor while they're in their class working out, collect all this biometric data, and they want to be able to surface up that data in their mobile app to their users to be able to slice and dice their data, ideally in real time, and get insights. And the challenge here is there's a ton of data. They have over 100,000 members, millions and millions of workout sessions, hundreds of billions of data points. And as I'm sure you all know, this is like a perfect use case for Clickhouse. The challenge is that they only had a couple developers, and they wanted to be able to do this complete re-architecture of their data and analytics backend in like a couple sprints. And so that's what we help them do with Moose. In order to do a re-architecture like this, you usually end up building something that looks like this. I saw echoes of this in the DoorDash presentation earlier. This probably looks familiar. You're going to need some kind of like real-time processing engine. Could be Python, could be Spark, whatever you want to use. You're probably going to want streaming buffers to set up topics in between the different layers of your data pipelines. You could use Kafka, Red Panda. You're going to want an analytics database, which you should use Clickhouse. And the challenge here is that what the F45 team wanted to focus on and what we wanted our data engineers at Nike to focus on was like the business level context. So the unique and interesting parts of your application, saying this is the structure of my data, these are the transformations that I want to apply to it. The problem is, in reality, you end up spending a lot of your developer time on boilerplate code. So you're doing boilerplate at the infrastructure level where you're trying to get your database to talk to your engine, your streaming engine, talk to your processing engine, configuring ports, setting environment variables, writing Terraform code. You're doing application boilerplate where you're having to move data from the topics to the table or to the functions and make sure it doesn't get dropped along the way. You're having to set up your local development environment, which can be really complicated. And I call this boilerplate not because it's easy, but because it's actually pretty complex. But it tends to be pretty repeatable, and it tends to look the same across many different use cases. And what we found is that this kind of highly complex but highly repeatable boilerplate is exactly the kind of thing that you can abstract away really effectively with a developer framework. So that's what we've tried to do with Moose. So a couple key features of Moose. I'm not going to go, there's many, many more that I could talk about, but I'm going to try to keep this quick. The first is 2 of the core primitives in Moose are data models and functions. I should have said actually to start, Moose is a developer framework that's available in both TypeScript and Python, so you can use either one, whichever you're most comfortable with. And it's going to surface up these primitives in those languages. So a data model is kind of the heart of Moose. It's where you define the structure of your data. And this becomes then a source of truth that you can use throughout your application, and it also informs all the underlying infrastructure that's generated for you by Moose. So when you define a schema as a Python class or as a TypeScript interface, Moose is going to automatically capture that schema and under the hood create all the tables and views in your Clickhouse database that are typed to that schema. It's going to create high-performance Rust web servers with ingest and egress API endpoints that are typed to that schema for you. It's going to put a Red Panda streaming buffer in between your ingress API endpoint and your tables in Clickhouse, and it's going to do all the glue and duct tape that you need to connect all those different things so that you don't have to worry about it. Similarly, with a function, you just worry about writing the business logic of your function. Like, I need to go from data model A to data model B. These are the transformations I need to apply. Moose is going to automatically orchestrate it for you, put the buffers in place, move data from point A to point B, and process that data for you. Hopefully you don't have to worry about the underlying infrastructure again. So let me show you, hold the thought on the last feature there. I want to show what these 2 primitives actually looked like for F45. So what you see on the left is the raw JSON data that was coming from the studios with all the biometric data in it. This is actually just like the top 10% of the JSON payload. It's a pretty complex nested JSON. It's got all the biometric data in it, but also information about the user and the studio and all this other information that's really helpful when you want to run analytics on top of that. So what they did in Moose then is just define essentially 2 data models, one that captured the structure of the raw data coming in. And you can see that this here is a TypeScript interface that is mapped to the structure of the JSON that's coming in. It turns out LLMs are actually very good at generating this kind of code from looking at data, which is a little preview of what I'm going to get to at the end here. And then they define the schema of the data that they wanted it at the end in order to run queries against it and power the APIs that were powering their front-end analytics experience. And then they defined a pretty simple function, which I don't show here, which mapped the raw session activity to the clean session activity. And then you just run and compile this code and run it, and all the underlying Clickhouse and Red Panda and Rust code and everything is kind of handled for you. They just push that into production, and it works. Okay, the last feature is the local development environment. Another thing that Moose does for you is it doesn't just run this in production, it's going to create a local copy of what the production environment would look like. So I'm going to show this actually working on my laptop here and give you an idea of what it looks like for like day-to-day development experience when you're using Moose. And yeah, hopefully this all works. So as a developer, I've got my front end running locally. This is just like a kind of a sample application that we want to get the heart rate data streaming to in real time. And then I'm going to go ahead and start a data generator, which is going to start creating a bunch of sample data locally for me. And then I jump into my IDE. And here I've got my Moose application. And you'll see with every Moose application, there's an app folder. The app folder is where all your primitives go. So we've got APIs and blocks, which I don't really have time to talk about today, but then we've got our data models and our functions. And when I run Moose CLI dev now, what this is going to do is it's going to spin up a ClickHouse container, a Red Panda container. It's going to create a node container with a node runtime. And this should start now. Yeah, so this is now starting to pick up the sample data that's coming from the data generator that's hitting that Rust API endpoint that we created. It's processing it through the functions, and it's making it available over API to our front end, which now has sample heart rate data flowing through it. Now, where this hopefully gets interesting is I can show you what happens as we modify this application in real time. like with a modern web development framework, it's going to pick up on those code changes and update the infrastructure in real time to let me see the progress that I'm making as a developer. So what I'm going to do now is start this Bluetooth connection. And I'm actually wearing a heart rate monitor right now. I'm not going to lift up my shirt in front of 50 people and show you, but it's actually in here. And what I want to do now is come back to my my Moose application, and I'm going to add a new data model and a new function so that we can start to capture this new structure of data that's coming off my Bluetooth heart rate monitor. So I've got my data model here. You can see it's a pretty simple data model. In this case, it's just, we got 4 fields. This is the data that's coming off the Bluetooth sensor. And I'm going to, actually, I'll quickly show you first before I do this. When I come to my local ClickHouse environment, we'll see within the tables that are running, we've got these data models. The data models have automatically created these tables. Can I make this? That might be really small. Let me see if I can make this any bigger. OK, a little bigger there. You'll see there's not the Bluetooth heart rate table is not there. But when I come here, I'm going to drop my new data model in my data model folder. And we should now see that Moose has picked that up. And when we come back to SQL, or come back to ClickHouse, we can see the Bluetooth table has been automatically created there in our ClickHouse environment. And then what I'm going to do is I've got a function here. Try to make this bigger so it's easier to read, but now it's all getting smushed together. Try and close this. So what this function is doing is taking the Bluetooth data model that we just added as an input, and it's returning the unified heart rate data model as an output. And it's just doing some simple mapping between those data models. By dropping the data in the unified heart rate model data model, that's the one that's actually powering the front end. So when I add this to my functions table, Moose should once again pick that up. You may have seen it flash by that it was processing the infrastructure changes. And now within, if this worked, where did my ClickHouse go? We should see data actually dropping into this table. Not seeing data. Oh, my Bluetooth connector crashed. Let's try that again. So this is scanning for the Bluetooth device and trying to connect to it. Looks like it connected. Now we see it's picking up data. Now we see there's actually data landing in the ClickHouse table. And now we should see me appear in the front end here. Come on. OK, this doesn't want to behave for me. That may be. It should still show up on the chart, though, actually. Oh, no, there I am. OK, so I don't know why it took a minute to show up there. I'm not quite as cool, calm, and collected as I would like to be. I'm at 100 BPMs, but I can take a deep breath and slow that down. When I was doing this at home on my laptop, it was at a constant 75, so I'm clearly nervous sitting in front of all of you. But yeah, that's Moose in a nutshell. Hopefully that gives you an idea of what like a developer experience is. So you can see changes happening live. Now this is all in the application, like it's in my GitHub branch. I can merge this into production, and Moose is going to automatically handle making the changes to the underlying tables and infrastructure to make it go live. OK, the last thing I want to show you really quick is the AI data engineer. So let me get back to my slides. So with Aurora, what we started to learn from using Moose is that if you abstract away a lot of the underlying complexity and essentially reduce the surface area of your code, it makes it so that not just any regular front-end developer or full-stack developer can create a full OLAP production stack. It also makes it so that any regular LLM or AI agent can create a full production stack, because now they're just interacting with regular TypeScript code or regular Python code through these Moose primitives. And so what we've started to hack together is a command line interface demo of this, where we pass in context, as much context as we can to the AI coming from all these different places, and have it actually generate our OLAP stack for us. So let me see if I can get this one to work. This one's particularly interesting because, as I'm sure many of you know, LLMs give unique and different answers every time you try to interact with them. So we'll see if this works. Actually, first I'm going to shut down my running environment, my demo, so that this doesn't interfere. Okay. And then I'm going to hop over to the Aurora demo. Here we've got a brand new, totally clean Moose project. So the app folder is totally empty. There's no primitives here. Clickhouse is not running. There's essentially nothing on my laptop now. What I'm going to do is start the Aurora CLI. I'm going to start this by pointing it at Anthropic, but this could be OpenAI or any LLM that you wanted to use. It's quickly going to just make sure that I have all the right dependencies installed, so I'm going to skip through this to get to the interesting part. And here we go. OK, so Aurora asked me, what type of data source am I trying to connect to? I could try to connect to a webhook or a WebSocket, but we're going to do an API. And it's going to ask me for the URL of the API. So I'm going to pass in a URL here. And from here, it's going to go through a series of steps to collect more context from me as the user and try to generate an entire ingestion stack for me just from that URL. So the first thing it did, my font's too big here. Let me try and give more room. Is it hit that API endpoint and pulled some data, and it's asking me if this is the data I expected. The URL is just an endpoint that provides the current Bitcoin price and the exchange rates into some other currencies. So this is the data that I expected. So I'm going to say yes. It's going to ask for documentation about the API. We found this is really helpful context to pass into the LLM. This API is not actually documented, so I'm not going to give it anything. It's now going out and scanning the latest Moose documentation, which is also very helpful context to feed into the LLM for it to build these primitives. And now it's done the first actual AI-powered thing, which is try to come up with a sane name for what we want to call the data model. It's funny, it comes up with a different thing every time, but here it came up with CoinDesk Bitcoin price index raw, which seems pretty reasonable. So we'll go with that. And now what it's trying to do is actually generate a data model based on all the context that it's collected so far. So we'll give this a second to run. And what you'll see is it's now generated a data model. It's actually dropped that data model into my Moose project, so I can see the code up here. And it's asking me if this looks reasonable. This looks pretty reasonable, so I'm going to say yes. Now what it's going to actually do is spin up a Moose dev environment in the background, try to compile this data model, run it, and see if it works. It looks like it actually did work, which is awesome. And now the last thing it's going to do is try to generate an ingestion script, which will hit that API endpoint, collect data from it, and push it into the new data ingestion pipeline that it just spun up on my laptop. While that's running, I can show you when we come back to Clickhouse, we've now got the table in here for CoinDesk Bitcoin price index raw, I think it was called. So it has successfully created the Clickhouse table. And now it's come up with a function that defines a couple interfaces, tries to fetch the data from the API. The LLMs are really good at commenting their code, which is awesome. It makes it very readable. This looks pretty sane, so I'm going to try and run it. It's now running the ingestion script. It says it succeeded and gave me an error at the end. So let's see what actually happened. I'm going to open up the table, and we do not have data in there. So it looks like it failed at the finish line. That is disappointing. What we should see here is one row of data in here if the script that it had come up with had actually succeeded at hitting the API endpoint. But what I can say is the whole infrastructure there of the high-performance Rust ingest API endpoint that's typed to the schema of that data model, the Red Panda buffer, and the Clickhouse table were all created by an LLM just by giving it a URL to try to create a pipeline for, which I think is pretty cool and maybe the future. So we'll see. That is all I've got. Thank you all for the time. Yeah. Moose is out there. It's open source. It's in public beta. It's powering some production use cases already. If anyone wants to go out there and get their hands on it, would love to hear your feedback.
Awesome. That was great. Great demo, Chris. Any questions for Chris?
Hi. Didn't ORMs kind of didn't work usually? Like why ORM for OLAP will work better than ORM for OLTP?
I don't know if I would say ORMs didn't work. I think it's a pretty popular technology, but I'm probably getting over my skis on the technical side there. I think, so what I showed you so far was not really like the ORM side. The ORM side would be more on querying data out of the database and extracting it. Where that was the two primitives that we didn't get to, which were APIs and blocks, are kind of the data egress side. What I focused on today was the data ingress side. We're exploring a couple different paths for how to make that data egress side more easy to use and intuitive and wonderful for the developer. Right now, blocks are essentially just ClickHouse SQL wrapped in a TypeScript or Python wrapper. So you do have kind of full access to the underlying database to construct your queries however you want. We're also, though, exploring some ORM-like or data frame-like interfaces to provide a more, a less SQL-y interface to the underlying database for developers who are interested in using that kind of interface.
How do you decide on the schemas and indices and things like this when automating the table?
So the schema itself is defined by the user. It's derived from the data model. You define the schema in the data model, and that becomes the schema of the table. The indices, so we've tried to kind of strike this balance of exposing the right level of granularity to configure the underlying database, and I'd love everyone's feedback if we've hit that right or not. But what you'll see in some of these sample data models is one of the things we do is we have this key property, which we provide with MooseLib, and you can label one or more of the fields in your schema as a key. So you get it right there at the TypeScript interface level as a tag on the field. That then translates to making that field actually a key in the underlying database at the ClickHouse level. Then there's also this separate configuration option that we have where you define your schema as an interface, but then you get this config interface for setting more granular configuration on what you want to happen on the underlying infrastructure. So you can do things like turn deduplication on, which at the ClickHouse level makes that a replacing merge tree instead of a merge tree, I believe, so that you get deduplication at the ClickHouse level. You can actually specify specifically your order by fields if that's necessary. So you get some of that configuration kind of bubbled up to you at the Moose primitive level.
What happens if you rename something?
So if it's in your local dev server, when you rename it, it's just going to blow it up and replace it with a new thing, so you make the change. When it's in production, it gets a lot more interesting. So this is something we've been exploring a lot, actually. We started by building a pretty magical automated experience that we call data change management that would try to, essentially when you pushed breaking changes into production, Moose would automatically manage running the old version in parallel with the new version and having parallel API endpoints for both ingest and egress, so that users could switch over to adopting the new version when they want, and then we would automatically generate functions that migrated the data from the old version to the new version for you, so you did your data migration. What we found actually trying to use that in production was there was a little too much magic there, and it didn't actually survive the test of reality. So right now, the way we're actually doing that with users in production, like with F45, is we're kind of manually recreating what was being done in an automated way there. So you get you have both versions run in production, you do a data migration, and then you shift over data producers or data consumers as they're ready to adopt the new API with the breaking change. So really, again, trying to take learnings and best practices from the software development world, which has figured out API versioning to a large extent, and bring that to the data engineering world.
Yeah, very cool. Yeah, thanks for everything.
Cool.